Okay, should be working. Ah, it's the blue screen from my webcam screen. It's reflecting off of me. But I am back for part 2. Last time I was working on these two boards. Well, technically a third, but it's still missing one part that needs to be soldered onto it. And thankfully they did arrive, so I will solder those momentarily. And then today I have 2 more boards to put together and start testing. One of them I've found some code that I think I can use to test it. The other one I will have to start from scratch, which will be lots of fun because I have, as much as I like using I2C devices, I have not done a lot of programming from scratch for them. So creating custom firmware for I2C tends to look like gibberish to me. So it's going to be an interesting learning curve. The power delivery board, however, I did find code for it. I have tested the code and it works, but the code is going to need changes. It does not have the best error handling built in. I'm sure there's a few other things that I'll find in the spec sheet when I go through it, just to double check a few things and see what kind of options there are. But it does actually work, which is cool. I had to go out and actually get a power delivery supply because I initially tried using a fast charger, which is capable of doing different voltages but is not compliant with power delivery. So it did not work. And that's how I found the issue with the code as well. But thankfully, it is working. I can make it work, and I'll demonstrate that a little bit later. Let's switch to my overhead view. So, well, I kind of wait for people to potentially join. Easy option is going to be to start with soldering these. So these holders go into place. You know what? To make it nice, well, the hard part is going to be keeping them aligned with the mount holes while I solder it. So I'm thinking the best bet is to put a couple of screws into it. I think these 10 mils are going to be too long. Yeah, that's way too long. I think I have some 6mm screws I can use. Here's one. That's not a hex key. That's a Phillips. Let's use these. 1 and 2. Actually, you know what? That'll be a little easier to work with, to be honest. I'll end up putting something in permanently, but for now I only want something temporary. It's just gonna be easier to grab my multi-driver set than go find a hex key. Although I'm pretty sure I know where my hex keys are. Let's see. Yep. There we go. Just a small amount sticking out the other end. Could use a nut, but using a standoff kind of keep it stable once I put it down, and then it's also easier to grab a hold of with my hands. Okay, let's get this one. Okay. That should make it a little easier to solder. Gonna need to swap out that brass sponge at some point. Thankfully I have a stash of it. That flowed really nicely. These are all flowing really nicely. Oh no! I didn't realize anyone was streaming right now. I just happened to be awake. I've had some terrible sleep this past week. Don't worry, I'll be here for a while, Johnny. You can always come back. That's why I'm saving my, I did some testing on these, so I can share that a bit later when people are around. I haven't spoiled everything just yet. Ooh. Yeah, see, with one of those CNCs that can do milling, I could see myself doing like breakout stuff with it, especially if I want to do a quick test. But an actual CNC, oh, I'd love to get my hands on like a 4-axis machine. Especially with designing my next e-trike. Be so nice to make custom parts for it. Although I'm still expecting that I will design custom parts that need machining. I'll either try and find a local shop, but a lot of the local shops like doing much larger tasks. So I have a feeling I might use an online service instead. It'll probably be easier and cheaper. It's a shame. You'd want to support local, but when it's 10 times the price and a whole bunch of other stuff, sometimes it's next to impossible to even get quotes. Unless they see you're a large company doing a bunch of stuff. Like, yeah. I've had to get stuff produced in the past for other clients, and you'd put out thing for multiple quotes, and a few of them are like, "Oh, you're too small of a business." Well, yeah, no kidding. I've only been operating for a few years, and I'm a one-man band. I can only take on so much work as a one person, and if I'm still building a reputation, can't really justify hiring people either. So, yeah, fine by me. I take the work that I like doing and actually enjoy doing, and I rely on word of mouth, and it tends to bring the better clients anyways. Man, this is soldering better than I kind of expected it to. Which, in a way, is probably a good thing. Stops you from melting the plastic housings while trying to solder. And it should also mean that you get good electrical connectivity out of these. Hopefully. I don't really expect to be pumping the amps through these. There we go. Now I got some battery boards. Oh, that's cool. So I was just wondering if the two, because the actual device I'll be building needs 2S. I was curious if it actually had mount holes, and thankfully it does. Those will be very useful for the device, because space is going to be limited, and putting outside holes might be a challenge, whereas using inside holes and being able to use it as a mount inside the scanner. See you later, Johnny. I'll be around. And then I can talk about the power delivery board. I learned some interesting things. Good things, though. All good things. Okay. Move that. Let's get some stencils. Yes, and charger. I think they're the last two I need to make. Yeah. I think I'm going to start by doing the charger first, because I think I can easily power it and test the I2C connection to see if things are working. I think that's going to be my best bet. Fun part is figuring out all the parts I need to pull out of my box. Build myself a custom desk, and I still need to get it organized. So I got parts and things that need to find their place. So this one has let's open up KiCad so we can double check part numbers. But the main IC is BQ25731. And it's in this package. Okay. Open the battery. We're looking at the charger. There we go. And those FETs are SQ S142. The 142 wasn't in stock, so I went with the next one up. Well, next few up, which is the SQ S160. Should be more than overrated. Hello, unexpected maker. Yeah, making progress on this project. I got these boards done the other day, and I have been able to get them to work, which is nice. Thankfully found some example code for them. Although the code needs some work, it doesn't have proper error handling, so I thought it was malfunctioning when it wasn't. But at least I have something to start with. Oh, Superhost too. How's it going, John? Yes, it is nice to have working boards. It also helps having example code to work off of. I can't remember which one it is, but one of these two that I'm still working on. I think it's the charger. I haven't found any code for it, but I did for the other one. It's one of them I couldn't find code for. So I get to learn how to make an I2C library. This one, I have some potential code that can work with some modifications. Yeah. I don't know, I've always tried avoiding like I like using I2C as a communication with a lot of chips just because it's easy to put a quick connector on things and test things, but every time I've looked at I2C programming, it's always gone right over my head. So I like, at least with these items, 2 of 3 of them, I have example code. So I'm hoping being able to look at example code and the spec sheets that I'll be able to deduce what's going on and learn. Okay, let's see. Need lots of parts for this. There's one capacitor. Oh yeah, you get the night where it's super productive and everything, and then you pay for it the next night. Had a few of those nights of late. Let's see. This one uses a whole variety of values. This is gonna be fun. Also uses an absolute boatload of capacitors. That is the tube. Oh, see, I thankfully printed off a combined parts list with all the parts these boards use, and I sorted them all into 2 boxes, so I have all the parts readily available, and it's somewhat organized in the box. Let's see here. Yeah, see, it's somewhat organized in the box, so I can push them aside and read them. The annoying thing with LCSC on the resistor packs is they don't write the darn label of the value, so I always have to Sharpie it on. That's the only annoying thing with that. But at least I can go looking for the parts. It's just a matter of figuring out which parts I need on which board. I just saw that part. That's the sense. Oh, yeah. Nope, that's the wrong one. 2.2. No. Oh, yep, need that one. Yeah, it's really something, that's for sure. I also hate the wide variety of bags they seem to use. Like, almost all of these I only ordered 100 of them because they're odd values that I'm not going to use very often. But they're all in different sized bags. 2 ohms. Where's the other one? I saw it somewhere. 4.9 ohms. No, that's 150. Some absolutely large inductors. Granted, this board is supposed to be capable, well, at least the IC is supposed to be capable of some serious power output, which is why I've used a rather large inductor for it, even though I expect I will be getting nowhere near that power level. I'd rather not cook my batteries. Feeling I'm just gonna have to pick most of the parts and then start placing them to see what I'm missing. Oh, this board doesn't have any LEDs on it. Thank you, Unexpected Maker. Enjoy your day. Have fun with your new assembly line. Do, 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 do. 33K, 82K. Picofarads, 33 picofarads. There's a lot of values on here that I don't think I've pulled out of this box. But I'm not gonna know for certain until I start placing them all. And I know I'm gonna need 10K, which is on a spool. I'm sure I have a bag of them somewhere too, but I'll use the spool. No. 100 ohm, no. 300K. No, that's the other board that needs that. I think that's everything. Yeah. Oh, stoked. Placing and solder pasting. Helps if I put the solder stencil the right way around. Definitely not the best method for doing a solder stencil, but it does work. I think I got all the pins. Oh, I missed 2. That's annoying. See, I really need to buy myself a solder syringe. I do not have one, and this paste I've tried putting into a manual syringe. It is too thick for it. Decent paste for the few bucks I pay on eBay for it, but for prototyping with, that works great. Do usually have good luck using my tweezers and dabbing it on. If anything, the pouch should stay in place during reflow, and I can touch it up with the iron. Oh, I order them with my PCBs from JLC. I wish I had a laser cutter to make my own. The shipping price they make you pay for a stencil's atrocious. I don't mind the price of the stencil, it's the shipping just jumps up drastically. Yes, I do. I do shrink it down. Originally, I'd order the stencil slightly larger and then like 3D print a bracket to help hold everything and align it, which is good if I'm doing like 50 boards, because I can tape the stencil to the 3D print and then just flip and pop boards out and do them really quickly. But I've actually kind of found it a little easier aligning and holding the stencil in place when it's the size of the circuit board. And granted, I'm normally only ever making like 1 or 2 of a board. If I have to make 10 or more, I tend to just use the assembly service for it. Tends to be both faster and sometimes cheaper, depending on how you want to look at your labor hours. Oh, there is an LED on here. I had a feeling I had at least one. One UF. I got one. Oh, actually, let's do this. Let's switch the camera. Turn on the light on the camera. There we go. There. So I got at least one UF there. One goes over there. That's 1, 2. I think one more over here. Yeah, that's 3. And I think that's all of them. There are only 3? I think so. Well, let's grab 3 and start placing. And I got 10 nanofarads. There are. I think there's at least one. Yeah, there's one there. Oh, I knew there was one more. Oh no, that's one nanofarad. I think that one's still in the box. Go find it. Let's see. It's 1, 2. I got 2. Got. Oh no, I need one more of these. So there's one over here. Keep grabbing these capacitors too low, and they stick to my tweezers. There we go. Need one more. That's handy, having someone that can help you. How are those water cannons coming along? They've been testing the one that you mounted to the truck? I always thought that was a pretty neat project to work on. Yeah, there it is. It's hiding among all these 10 UF. I need to go in. Right there. And this board definitely doesn't have enough capacitors on it. My goodness. Now granted, I am following the reference schematic, which is from a breakout board from the company. Just 20 times the cost. $80 of those cannons. What? That's awesome. I was watching a video the other day of well, that's cool. Watching a video of those Striker, I think is the name of the company. They make airport fire trucks, among other things, I'm sure. And I was watching a video from a trucker who was hauling one to a port because it was going overseas. And they're going through the procedure for locking the brakes, making sure it's tied down properly and that it's not going to move, and to make sure the door is properly latched because it's all air driven now. And the way it operates is, of course, everyone in the comments is like, why would you set it up that way? That is so silly. Because if you lose air pressure or whatnot, your door basically goes flying open. So when it's being shipped and towed, it has to be manually locked in place. It's, yeah. Cool vehicle, but some of the things on it kind of make you scratch your head. One, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Count 18. That is true. That is true. Actually, that reminds me, one of the cool things I found when I took my welding training at a college is part of the, I think it was the Millwright program. They would pair them with another program that was more engineering and design based. I can't remember exactly what program it was, but one of the projects for both of those types of courses, or diploma I should say, was that they'd pair them up with a project, and they'd kind of have to create their own device, but then actually be able to machine it and build it. But you'd have to make proper blueprints that your machinist could follow. And I always thought that was a great program addition, because the more common thing people run into in the field is that an engineer designs it one way and then the person has to be able to build it, and they're like, well, how in the world did you actually expect to build this? 12, 13, 14, 15, 16, 17, 18. It should be 18. Yes, indeed. I think even as a general consumer knowledge, people should try and have a better understanding of how things work. Like, most of our education system is still the same way it was hundreds of years ago. Kinda seems weird that so many things are changing, but you wouldn't change the way you try to teach. Thankfully, I feel like I got lucky and had good teachers that would understand someone's aptitude for things and the desire to learn extra and learn very specific things, that they were willing to foster it. I had a few opportunities throughout school that I felt were great. And then, of course, the big part is always not just critical thinking, but the curiosity and the ability to problem solve. Spend so much time making people good at taking tests and whatnot, but not actually being able to critically solve a problem. And then businesses are like, the person can't do anything. Had that conversation with many tradespeople that would come through my college, because they were contractors fixing stuff, and they're like, oh, I try and hire an apprentice, and you have to spoon feed the information, but then you go to another job and they can't transfer some of the things you're trying to teach them. Granted, it also comes down to teaching style, too. Can go both ways. Oh no, why is it misaligned? Looks like I only need one of these. This is 2.2 UF. I'm definitely excited to see how that PoE board works out for you, John. Granted, the video has been doing quite well, actually, for views. On top of the number of people that seem to be interested in the design. I've been holding back from uploading it right away to GitHub, because I kind of want people to actually understand how it works first, before just immediately copying the design in case it isn't actually what they're looking for. But from the sounds of it, quite a few people are interested in it. Oh, I missed a few capacitors. Nope, that's new. Need at least two more. They go over here. That one. Now, these ones are supposed to be 33 UF, although I'm realizing I put UH on the silk screen. Whoops. That is not the right unit of measurement. But I made a mistake because I bought a size smaller of these tantalums. That one was indeed supposed to be 10 microfarads. These ones were supposed to be 33. But I'm not really expecting big power draws and to be connecting and disconnecting stuff for these. So I think these will be fine. And they're large enough that if you needed to, you could desolder them fairly easily and put the right value in. But seems silly to order a whole bunch of new parts just for one capacitor. Spend $8 shipping for $2 worth of parts. 2.2 ohms. I think there's only one spot that uses it. It's for one of these capacitors. There we go. Don't think I need them anywhere else. Probably gonna leave that inductor to last because it's so darn large. $15 picofarads. There's one. Just the one, I think. Oh, no worries, John. All is good. Not the only person that likes using my stream as background noise. Plus, I thankfully have the ability to sit in silence. Well, not really in silence. I got a YouTube playlist going, but I don't mind having silence when talking. But I like having a live stream going because, one, it forces me to actually do the work. Two, I like showing off the work I do. And people are always curious how boards get made and assembled, and I think this is a good way to do it. That's the capacitor I just did. Yeah. Live stream's a good way to show why things take time. Especially when you have a design like this that uses every other value in the book. Nope, not on that board. One, two, three, 4, 5, 6, 7, 8. Eight 10K resistors. 1, 2, 3, 4, 5, 6, 7, 8. Almost lost that spool. Oh my god. Oh no, I almost did it again. Okay. Oh, I actually didn't need 8 of these. Oh well. I'm gonna leave the ones for the pull-up off. Missing one? Or did I pull one extra out? I think I pulled an extra. Yeah. Okay. .2 is one of these. 40.2 ohms. Oh no, kilo ohms. That goes right here. .82 kilo ohms. I think there's only one of them. I think right here. This is for the selection of what battery you're charging. Although I find it odd that this is a selection and not a programmed thing. Although I think it's a combination. Or I wonder if you can do either or. Should dig through the spec sheet, to be honest. So if you didn't have to place these puts, it'd be kind of nice. Although granted, this is a breakout board, so I've got the option to select few. When I build it into the actual device I'm building, I can just use the 2 resistors I need. Next one is 33 kilo ohms. Ooh. New space discoveries. My goodness. Space is such a cool topic. Absolutely fascinating research those folks get up to. .100 kilo ohms. That goes on the other side of the resistor divider. And got 33 nanofarads. I got 1, 2, 2 spots by the look of it. Make sure the value is right. 33 nanofarads. Right there. One goes there. The other one goes there. And 4.7 nanofarads. This is 4.7, yeah? 4.7. There is 1. It's over here. And the other one I have pulled out is 100 picofarads. There's 1, 2. Let me see. Yes, 2 spots that I see. What there? And 1 right here. Okay, more searching for parts. So, I know I need an LED. There's the LED. 30.1K, yep. 191K, yep. That is 680 picofarads. Yep. 15K. Yes. One nanofarad. Thought I saw that somewhere. Yes, there's one spot. 220K. Yes. Yeah, there's my sense resistors. Ten nanofarad. No. $470 nanofarads. Is that nanofarads? Yeah, that's nanofarads. No, don't see that. $150 ohms. No, I need 150K though. 47 nanofarads. Yep. Ah, there's 150K. Still missing a few, I know. If it's in this bin. Ah, there we go. There's 100 nanofarads. Oh, like 10 ohms. Was there 100 ohm? I don't think there was. No. I think I have everything now. Okay, let's see here. 10 ohms, there is 1, 2. There's the 2, I think. No, there was a third one. Yeah, there's a third one. Oh no, I dropped it. And the other one goes over here. 100 nanoferts. I got 1, 2, 3. Oh, there's more than that. Really? Just the 3, I guess. 2, 3. Well, at least it's not like most designs where people are like, oh, there's issues with power. I'm just gonna sprinkle a bunch of these. Now, granted, there's so many 10 UF capacitors on this that I think it's odd, but it is based off a reference schematic, and considering it's a breakout board where you might have weird connections and stuff, it can probably save you from burning things out, so I'd rather follow the reference and then not have it work than not follow the reference and not have it work. If that makes sense. I think I repeated myself. Uh, 30.1 kilo ohms. That's 1. Yeah. There we go. $150 kilo ohms. There's one of them. Thank goodness resistors are cheap. So many different values. Values that I'm not likely to use very often. Come on, UPS. Ah, still no update on my delivery? Darn it. Hopefully it starts moving again. Really like to get my package. Well, let's put the LED in place. Oh, this is the LED without the marking on it. Oh, it's so annoying. Thankfully, I have the multimeter handy. I just need leads. Ah, okay. So it has a very fine amount of copper on one of the pads. And that is your ground indicator. Whereas normally on this size of LED, you have a green line that helps indicate which way it goes, which is much easier to see with the eye. But I checked with the multimeter, so in it goes. If I wanted to be sure, positive, negative. Yep, there we go. Obviously, it'll be easier to test that once it's actually flowed the solder. But this is the right way around. Let's see. 191 kilo ohms. There's one of them needed. One over here. Yep, there we go. .47 nanohertz. There are two of those. Let's just make sure. Yeah, 47. And he's pretty close with the eye. Let's see. Let's put the sense resistors in place. This uses 10 milliohms. I think these are 2-watt resistors. Yep, 2-watt, 2512 sized resistors. We got one. For something that can handle so much power, they're super thin. 220 kilo ohms. And need one of them. Make sure that was the right one, yeah. 220 kilo ohms. It is a snowing mess outside. And we're supposed to get freezing rain on top of it, which will be absolutely joyous to clean. $680 picofarads. Need one. One nanofarad. There's one of them used. Right there. And 15K. I haven't found my 380K resistors. Should go check my order sheet and see if I actually ordered them. I hope so. So other than the main IC and the MOSFETs, I'm just missing that one resistor. Let's see. I have a printout of the parts. See 300K. Oh no. No, I got 380K listed here. Oh no. I ordered 330, I think. Not 380. Yeah, what I ordered is 330 kilo ohms, not 380 kilo ohms. Let's see. See if I can't find the document and compare what that resistor is used for and whether or not I can change it. that resistor is connected to where? It's a voltage divider. Oh, it sets the frequency, I think. Which means it might end up being a critical part. Let's see here. So right now, I'm looking at the... Oh, hey, Johnny. So I realized I ordered an incorrect part. So I was supposed to order a 380 kilo ohm resistor, and I ordered 330 ohms. So I'm seeing if it's possible for me to change it. So 2530, 2531, 731. This is the chip I'm using. This resistor. This resistor is between pin 7 and pin 6. Let's see here. There's pin 6. Oh no! Oh, that sucks. See, this one's 383K. So that's pin 6. It goes up to pin 7. 10 ohm. Do I have that 10 ohm in place? I don't see that 10 ohm. So there must be a reason I've changed it. Pin 7 and 6. So what is pin 6? Input current setting. Pin voltage is calculated. Oh, it's the input current limit. High impedance with low quiescent current. The pin voltage is above. Used for updating current limit setting. Oh, so you can use it for adjustable current limit. So if I left it off, it wouldn't try charging. So I can probably get away with putting the 330k resistor in. The other one I want to know, so there's a way to put it in a mode where you don't have the batteries hooked up, which will be good for testing, because I don't really want to go poking for batteries. It is... I scroll up on this. They put things in a weird order in this document. Here we go. Jumper 2, forward mode, enable on the go. Ideally, I'd have it in that mode. Oh, yes, it's very complicated. It was one of the better ICs I could find for this task, too. Both this one and the BMS chip are kind of complicated, but they had some of the better documentation of some of the chips out there, which is why they got used. Not necessarily. So, I might have to end the stream early. I'm just noticing something on my security camera, so that's why I'm a little quiet at the moment. Yeah, I'm going to have to pause for a minute.